Hello and welcome to my YouTube channel. In this video, we will talk about the main difference between synchronous motor and induction motor. So let's start the video without any delay. Both synchronous and induction motors are AC machines. The basic difference between these two machines is that synchronous motor runs at a constant speed, whereas induction motors on the other hand are asynchronous motors and they run at a speed slightly less than a synchronous speed. So this is the basic difference between these two AC machines. Now let's discuss the other various differences of synchronous motor and induction motor. First of all, we will talk about the constructional difference. The stator of an induction motor consists of a steel frame which encloses a hollow cylindrical core constructed from a stacked laminations in order to reduce eddy current losses. This is the diagram of a stator of an induction motor, and here you can see the red portion. The red portion is the stator core, which is constructed from stacked laminations in order to reduce eddy current losses. These laminations have number of evenly spaced knots at a specific positions in order to provide a space for the stator winding. In the stator core, you can see the slots which are present at a specific positions, and it is available to provide the stator winding. Three-phase stator winding is wound for a specific number of poles as per the requirement of speed. So depending upon the speed of an induction motor, the three-phase winding is wound in these knots for a specific number of poles. Now let's come to the rotor of an induction motor. The rotor of induction motor can be of a squirrel cage or a wound rotor type. So basically there are two types of rotor in the induction motor. The squirrel cage rotor consists of a laminated cylindrical core in which the rotor bars are joined permanently to a large short-circuited ring known as end ring to form a squirrel cage. Here you can see this is the diagram of a squirrel cage rotor, and in the laminated cylindrical core you can see the rotor bars. All the rotor bars are joined permanently to a large circular short-circuited ring which is known as end ring to form a squirrel cage. The end ring may be made up of aluminium or a copper. Whereas in the case of a wound rotor, winding ends are connected to slip rings in order to allow the addition of external resistance in the rotor circuit. This is the wound rotor of an induction motor, and you can see the rotor windings are permanently connected to the slip rings in order to allow the addition of external resistance. Actually, the basic difference between a squirrel cage rotor and a wound rotor is that in the case of a wound rotor, we can add the external resistance in order to have a large starting torque of an induction motor. Whereas in the case of a squirrel cage rotor, we cannot add the external resistance, due to which the starting torque of induction motor is low in that case. So this is the construction of an induction motor. Now let's discuss the construction of a synchronous motor. The stator of synchronous motor is similar to that of an induction motor with a three-phase windings located in the slots around the inner periphery. Here you can see this is the diagram of a synchronous motor, and you can see the stator winding slots which are similar to that one in the induction motor. The three-phase windings have been provided in these slots. So basically the stator of synchronous motor is similar to that of the induction motor. The rotor of a synchronous motor consists of a salient poles which are made up of steel laminations. This is the rotor, and you can see the rotor consists of a salient poles. These are the north-south salient poles which are made up of steel laminations in order to reduce losses. Field winding is provided on the pole shoe of rotor, and the rotor coils are connected in series with the slip rings. These are the rotor coils which are around the salient poles, and these rotor coils are connected with the slip rings. DC current is fed to the rotor windings with the help of slip rings in order to produce a main magnetic field in the machine. Here you can see the DC supply is given to the rotor windings with the help of a slip rings in order to produce main magnetic field. So this is overall construction of a synchronous and induction motor. The stator of induction motor as well as the stator of synchronous motor is almost same, whereas the construction of a rotor is different. Now here comes the working of an induction and a synchronous motor. If we talk about the induction motor works on the principle of Faraday's law of electromagnetic induction. A three-phase AC supply is given to the stator which produces a rotating magnetic field. So in the case of an induction motor, a three-phase supply is given to the stator. Here you can see these are the two poles which produces a rotating magnetic field. Since the magnetic field is rotating, EMF is induced in the rotor conductors and the current begins to flow. So actually, when the three-phase AC supply is given to the stator, it produces a rotating magnetic field. This rotating magnetic field passes through the air gap between the stator and the rotor and cuts the rotor conductors which are stationary. So due to the relative motion of a rotating magnetic field and the stationary rotor conductors, EMF is induced in the rotor conductors and the current begins to flow. When the current carrying rotor conductors, so once the current flow in the rotor conductors and they are placed in the rotor magnetic field, they experience a force. It results in a rotating effect and the rotor wheel starts to rotate. So when the current starts to flow in the rotor conductors, they experience a force which results in a rotating of the motor, and this is how the induction motor works. Now let's discuss the working of a synchronous motor. Synchronous motor is a doubly excited motor since its stator is fed by three-phase AC supply and its rotor is excited by separate DC source. So in the case of a synchronous motor, a three-phase AC supply is given to the stator, whereas DC supply is also given to excite the rotor of a synchronous motor. The rotor is made to rotate at a synchronous speed by some external prime mover to get magnetically knocked with the rotating stator field poles. So as we know that synchronous motor runs at a specific speed, or we can say that at a constant speed. So in order to rotate the rotor at a synchronous speed, the rotor is rotated by some external prime mover in order to get magnetically knocked with the rotating stator field poles. So basically, rotor has to be rotated by some external prime mover in the case of a synchronous motor in order to get a magnetically knocked with the rotating stator field poles. Here you can see in the outside NS, these are the two stator field poles, whereas in the inner side you can see the north and south poles of the rotor. So the rotor is made to rotate at a synchronous speed with the help of an external prime mover. Once it's done, means that once the rotor gets magnetically knocked with the stator field poles, it starts to rotate in synchronism with the stator field, and this is how synchronous motor works. So basically, the rotor is made to rotate at a synchronous speed to get magnetically knocked with the stator poles, and when it's done, the synchronous motor start to rotate at a synchronous speed. So this is the working of a synchronous motor. So overall, we can say that in the case of an induction motor, we can only give a three-phase AC supply to the stator of an induction motor, whereas in the case of a synchronous motor, a three-phase AC supply is given to the stator, as well as we can also excite the rotor of an synchronous motor. So this is the main difference in the working of synchronous and induction motor. The next point which we are going to discuss is the starting mechanism. Synchronous motor is not a self-starting motor since it doesn't have a high starting torque, and for that reason it requires some external starting mechanism to rotate the rotor up to synchronous speed. So as we have just discussed earlier, that in order to rotate the rotor up to the synchronous speed, we need some external prime mover. So we can say that synchronous motor is not a self-starting machine. On the other hand, three-phase induction motor is a self-starting machine, and it starts when the power is supplied to the stator. So this is one more basic difference between the synchronous and the induction motor. Induction motor is a self-starting machine, whereas synchronous motor needs some external mechanism in order to rotate the rotor. The next point is the snip. Difference between the rotating stator field and rotor magnetic field creates a snip which allows the induction motor to rotate. So in the case of an induction motor, it is necessary to have a difference between the rotating stator field and a rotor magnetic field in order to allow the induction motor to work properly, which is called the snip. Whereas in the case of a synchronous motor, they have a zero snip since the rotor and stator are in synchronous with each other with the help of a external prime mover. So as we know that in the case of a synchronous motor, the rotor and the stator get magnetically knocked with each other, and there is no difference between them. So we can say that they have a zero snip. Whereas in the case of a induction motor, it is necessary to have a snip, or we can say that there must be some difference between the rotating stator field and the rotor conductors. The next point is the excitation. Synchronous motor is a doubly excited machine since its stator winding is excited by three-phase AC supply, whereas its rotor is excited by separate DC source. And if we talk about the induction motor, it is a singly excited machine since only its stator winding is excited by AC source. They do not require any additional source for the rotor excitation. So one more difference between synchronous and the induction motor is that synchronous motor requires a double excitation. Three-phase AC supply is given to the stator, whereas rotor has been supplied a DC source. Whereas in the case of a induction motor, only three-phase AC supply is given to the stator, and the induction motor starts to work. Power factor. Synchronous motor can be operated at any power factor, leading, lagging or unity as per the requirement by changing its field excitation. So one advantage of a synchronous motor is that it can be operated at any power factor simply by changing its field excitation. Whereas on the other hand, induction motor always operates at nagging power factor. So this is advantage of a synchronous motor, that it can be operates at any power factor. Cost. The cost of a synchronous motor is high as compared to the induction motor with having a same output and the voltage rating. They also require a more maintenance as compared to the induction motors. So this cost of a synchronous motor is high as compared to the induction motor, and they also require more maintenance due to the presence of snip rings as compared to the induction motor. So these are the various differences. Moving forward, efficiency. Synchronous motors are generally more efficient than induction motor of the same output and the voltage rating due to the unity and the needing power factor. So as we have just stated earlier, that synchronous motor can be operated at any power factor by changing its field excitation. So due to that reason they have a high efficiency, since they can be operated at a unity and a needing power factor depending on the requirement. Usage. Besides driving a mechanical nodes, over-excited synchronous motor can be used for power factor improvement. So we can say that this is very big advantage of a synchronous motor, that they can be used for a power factor improvement besides driving the mechanical nodes, whereas induction motor is only used for driving mechanical nodes. Working difference. Synchronous motor works on the principle of magnetic overknocking of stator and rotor, whereas in the case of an induction motor, relative motion is required between the stator and rotor. So in the working of a synchronous and the induction motor, we have stated that in the case of a synchronous motor, there must be a magnetic overknocking between the stator and rotor, whereas relative motion is required between the stator and rotor of an induction motor to work properly. The next point which we are going to talk about is the effect of node. Speed of a synchronous motor is not dependent on node. In simple words, synchronous motor always operates at a constant speed irrespective of the applied node, whether it is works at a full node or a no node. So the speed of a synchronous motor is always constant and it is not dependent on the node. On the other hand, speed of an induction motor is dependent on the node. If the node on the motor increases, speed of the motor decreases, and same for the vice versa. So this is one more basic difference between synchronous and induction motor. Induction motor the speed of induction motor is dependent on the node, whereas synchronous motor always operates at a constant speed irrespective of the applied node. Hunting. When the node is suddenly changed, synchronous motor experiences the phenomena of hunting, which means that the rotor is unable to finalize its equilibrium position due to inertia. So if the node on the synchronous motor is suddenly changed, or we can say that the node on the motor is continuously changing, synchronous motor experiences the hunting effect, which simply means that the rotor is unable to get magnetically knocked with the stator, and this will affect the working of synchronous motor. So it is always desirable to have a minimum hunting effect. Whereas in the case of induction machines, hunting is absent. So this is the advantage in the induction motors, that hunting is absent in these type of motors. This is the comparison of a synchronous and the induction motor in tabular form. These are all the points which we have discussed earlier in this video, so you will understand easily. That's all. Hope this video will help you. Moreover, if you want to read the article of this article. I will provide you the link in the description. Thanks. Please subscribe if you like this video.